And if you want to pause right away to read through this here these are conjugate roots and Descartes' rule of signs. Feel free to do that. I'm going to do this problem here for you now. So if one of my zeros is this kind of root where it has an imaginary or a radical in it, we know that if x equals 4 minus I root 2, that x minus 4 minus I root 2 is the factor that gave me that root. We also know that because of the conjugate rule, that if this is 1, then the conjugate of it will also be a root. So with that in mind, if that's a 0, then x minus 4 plus I root 2 is also going to be. So if I FOIL those together, I'm going to get x squared minus 4x plus I root 2x. And then I'm going to distribute the negative 4 to all of them, and I get a negative 4x plus 16 and minus 4I root 2. Notice that I'm lining up like terms with each other. And so I'm going to distribute the minus I root 2 next. So I'm going to say I get negative I root 2x. I get positive 4I root 2. And I get a negative I squared times 2 at the end. And if you line up the stuff the way I did here, notice that these two are opposites and these two are opposites. So they just go away, and my leftovers are going to be 8x plus 16. And then I squared is the same as negative 1. And that's going to give me a negative 1 times 2, which gives me a 2. So we're going to say that this is the polynomial that has these two roots. So if I want to determine if this is a factor of that, I'm going to have to use my long division. So I'm going to say x squared minus 8x plus 18. And I'm going to divide that into, making some room for me, 4x to the 4th minus 32x cubed plus 81x squared minus 72x plus 162. And a little more room. There we go. All right, so now let's see if how many times does x squared go into 4x to the 4th. That gives me 4x squared times. So it goes in there 4x squared times, and I get 4x to the 4th minus 32x cubed and plus 72x squared. And I am subtracting, so these go away, and I'm left with 9x squared. Bringing down some more terms. And I'm going to put in a plus 9 in there, which gives me 9x squared minus 72x plus 162. And it comes in there 0. So it is, and let's find the roots of that. So I know that equals 0, so I get an x squared equals negative 9 fourths square root. I get x is equal to plus or minus 3I over 2 would be the rest of those roots. So here's how Descartes' rule of signs works. every time it goes from a positive term to a negative term to a positive term to a negative term. We have how many changes in signs? 1 change, 2 changes, 3 changes. So we have 3 changes. That means that there are 3, or because all roots come in conjugate pairs, we could, or imaginary ones or the rational ones come in conjugate pairs, we could have 2 less than that. So 3 or 1 positive rational roots. In this one, if we look, that's a negative term, that's a negative term, that's a positive term. So there's only 1 change. So this one has 1 positive root. This one's positive, that one's positive, that's negative. So there's only 1 change, so that would be 1 positive root. Now to find out how many negative roots there are, let's go back and change all of this. If I change this by plugging in negative x in for x, so I'm going to put in negative x to the 4th minus 3 negative x squared plus negative x minus 1. And simplifying that down, when I take negative x to the 4th, it just becomes 2x to the 4th. Same here, that one doesn't change anything. So let's look, we only have, that's a positive, the negative, negative, negative. So we have 1 change here, so there's 1 negative root. If we do the same thing with the rest of them, we're going to find out that well, let's do this. And if I plug it in, I get negative x cubed, negative x plus 1. So I get a 2x cubed plus x plus 1. So there's no changes, so there's no negative roots. All right. And you can do the same thing for this one on your own time. So that's what Descartes' rule of signs means. So if you take and pause this and read through there, that's what we've done. All right. So Descartes' rule of signs, I'm going to have 1 positive because there's 1 change. And if I do it with the negatives, I'm going to have 2 or 0 changes that are negative roots. And go ahead, substitute in and see negative x in for x and simplify and find those changes. Over here, we're going from a positive, positive, negative, negative, so there's 1 change, so there's 1 positive root. And if you substitute in there, I get negative x to the 7th plus x squared plus x minus 1. And so I have 2 changes, so 2 or 0 negative roots. And we're not sure what they are. So let's look at example number 6. For positive values of C, D, and E, show that the equation has 1 positive root and 1 negative root and 2 non-real complex roots. So if I go ahead and we know that C, D, and E are positive, and I plug in, so I have a positive, 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 and that would be 1 change. So that shows that there's 1 positive root. If I substitute in there my negative x, I get negative x to the 4th plus c times negative x squared plus d times negative x minus e. And this becomes x to the 4th plus cx squared minus dx minus e. And there's only 1 change there, so there's 1 negative root. And if there's 1 positive root and 1 negative root, and it's a 4th degree polynomial, the other 2 have to be non-real. complex. So 2 complex. So we showed that. All right, so again, if we have find the polynomial in the lowest degree with an integer coefficient and leading coefficient of 1 such that that is a root. So if that is a root, then that has to be a factor. And if that's a factor, then this has to be its conjugate. If I take the time to multiply that out, I get that I have x squared, and you can pause right here to multiply it out, but I get x squared minus 2 root 3x plus 7. And if I have to have integer coefficients, which it says there, we really don't have integer coefficients there. So if I want to get rid of that, I know that if I multiply it by its conjugate, and that's not the nicest conjugate, but I'm going to have x squared plus 2 root 3x plus 7. Notice that my middle term sign has changed. And if I FOIL all of that out, I'm going to, and you should take the time to do this, pause it and do it, I get x to the 4th plus 2x squared plus 49. And so now I have all integer coefficients that give me that root. Could there be one in the cube world? Maybe. Maybe somebody should work on that, see if we can find one that's a cube that would get rid of that. I'm not sure that there is, though. All right, so last thing we have to do is partial fraction decomposition in section 12.7 and 12.8, and I'll do that on a separate video. So we have a video for 12.5. That was the first one. This one's the 12.6. So we're going to pause this, stop this here, and do partial fraction decomposition next.